Yeah, I said we're going to prove the mean and the variance of the parameter beta hat. That is the OLS estimate, or the OLS estimator of the regression model. Alright. So, what we have now is, first, we need to find the expectation of B hat. That is, we need to find the expectation of the OLS estimate, because the expectation of the OLS estimate is the mean, right? So we need to find what it looks like. Okay. Now, finding the expectation is the same as x prime of x inverse x prime of y. Okay. Now, we don't want y to be part of this. Okay? We don't want y to be part of the scheme of things. So we have to replace it with x prime x inverse x prime y. But we know what y is. Y is what? xb plus what? Plus e. Where b is the true parameter, right? Beta hat is the estimator. Okay, please. It is conventional for me to put this hat on top to tell you it is what? An estimator. Okay, if there is no hat, it means that is the true parameter that we are estimating. Estimator. No, estimator. Estimator is a formula that you use. Okay, maybe you guys should just write this down. I know sometimes it can be very confusing. An estimator is a formula used in obtaining the estimates of a parameter. It's a formula. An estimator is a formula you use in obtaining the estimate of a parameter. Okay? Why an estimate is the result from a process of estimation.
Please come again. Estimator is the formula used.
Yeah, it's the formula used in obtaining the estimate of a parameter. It's a formula. For example, we call this an estimator. We call that an estimator because it is a formula used in obtaining the estimate of a parameter. While an estimate is the result of using the what? The estimator. Okay, it's the result you obtain by using the estimator. That's estimate, right? While estimation is the process of carrying out what? Is the process of finding that estimate. Okay. But what I want you guys to take note of here is the fact that an estimator is a what? A formula. It's a mathematical formula. Yes. Now, okay, if you come here, we have x prime, x transpose x inverse, x transpose y. But we already know that y is what? X beta plus what? Plus e, from what we already know. Okay. So if we expand this, we're going to be having expectation of x prime x inverse x prime of x beta plus x prime x inverse, okay, x prime x inverse x prime and what? E. That's what we have, right? Okay, I just expanded this bracket. Now, this gives us expectation of, you see, we're multiplying the inverse of a matrix by the matrix. So what is it going to give to us? The identity matrix. This will go away as we found out before. So we're going to be left with B, right? B plus x transpose x inverse x prime of E. All right. Now, if you check this out, B is a constant, right? B is a constant. The expectation. So let's find the expectation. This is the rule of expectation. The expectation of x plus y is equal to expectation of x plus expectation of what? Y. The expectation of ax is equal to a expectation of what? Of x. Where a is what? A is equal to a constant. So, alright. So if we apply that same rule, and of course, the expectation of C is equal to C, where C is what? A constant. If you find the expectation of a constant, it's going to give you the constant. Okay. Please, those side notes, I'd like you to write them down. They are really important. Okay. Now, if we come here, let's find the expectation. You know the expectation. Okay. All right. Yeah, this line.
Yes. We are multiplying x plus.
Yeah, everything here to multiply this, to arrive at this.
Everything.
Yes, of course. You know, this is multiplication, right? So,
Yes.
you're welcome. Okay. It gives what? Yes, then here, you see what's happening? This is inverse. Multiply the matrix itself. It's going to become 1. It goes away. That's why we're left with B here. But this will definitely subsist. Okay? Alright. So let's find the expectation. Let's find the expectation of this now. Okay, using that rule, it's going to be what? Expectation of B plus expectation of x prime x inverse x prime of E. Okay? That's it. That's what we're going to find. Does this make sense? It's like saying B is x and everything here is what? Y. So expectation of x plus y is equal to expectation of x plus expectation of what? Y. You see, that's why I have to be detailed with those rules. So that I don't want us to rush things, okay? We just have to take it systematically. Now, having explained this, but B is a constant, right? So what is the expectation of B? B is what? Is B. Good. Since it's a constant, so we're going to be left with B plus, now, x, this matrix here, x transpose x inverse times x, they are also constant. They are also constant because they are set of fixed values. Yes.
But it should be divisible.
No, it doesn't work that way. Don't look at it like that. Okay? It should not be divisible. Yes. This very line? Okay, why it's like this? Okay, good. Where do I start from? But you understood how we proceeded from here to this place. This place? Okay. How we got here is simple. Use this entire matrix to multiply this xb. You arrive at this. You got this part also. Okay, it's now here that is the problem. Okay, how we arrive here? X transpose x inverse times x transpose x. It's going to give you identity matrix, which is 1. Then it will leave B alone, right? But here we can't do the same because there is no x to complete it. If there was x here, E would have been left alone, right? Okay, but it's not complete. Okay, hello, did you get it now? Okay, all right. Let's proceed. Okay, thank you. So, you guys also understood how we proceeded from here to this point by virtue of those rules. Now, these are constant. These are constant. They are not parameters. They are not random variables. So what happens here is this becomes what? X transpose X inverse X expected value of what? E. Does it make sense? It does make sense because expectation of AX is equals to what? A times expectation of what? X. If and only if A is what? A constant. Yeah. Okay, X transpose. Thank you. So, since I've already said that everything here is a constant, it means it will go to the back of what? The expectation. But E is not a constant. E is a random variable, right? In the assumption, we've already stated that E is a random variable that follows the normal distribution. So, the expectation always applies to what? The random variable. Alright. Yeah. So, what I'm saying is this. This expectation of B, we took the expectation because B is a constant. What happens? It remains the same. Expectation of B is B because B is a constant. Now, we want to take the expectation of everything here. And I said x prime x inverse times x inverse is a constant. They are constant. They are fixed values. Right. So, If they are constant, by virtue of this rule, it means they're going to go to the back of the expectation, right? Then we find the expectation of what? E, because E is a random variable. We stated that assumption before, right? Great. Now, the next question that comes to mind is, the expectation of E is what? Is 0, right? That was the first set of assumptions we made, right? So, it means the expected value of beta hat will be equal to what? B, because everything here will go to what? To 0. So, the expected value, what this implies is that the expected value of the OLS estimator is equal to what? The true value of that parameter. Okay, when the mean of the estimator, please, when you hear me say expected value, I'm also referring to what? The mean. When the mean of the estimator is equal to the true population value, we say that that estimator is what? Unbiased. So that is how we got the term unbiased estimator. Yes, I said when the expected value of an estimator, when the expected value of an estimator is equal to its true population value, such an estimator is said to be what? Unbiased. Okay. Such an estimator is said to be what? Unbiased. Yes. Yeah, that's it. The mu is the population value. Yeah, it's the same thing. Yes. When the expected value of an estimator is equal to the true population value, we say that that estimator is what? Is an unbiased estimator. Now, we have already found the mean. Let's find the what? The variance. Variance is variance of beta hat will be equal to the expectation of beta hat minus what? B, right? You know why we are having B, right? Because B is its mean. We just found the mean now. Alright. Then, for it to be square, we need to write it again and transpose. Right? So we're going to be having beta hat minus B transpose. So, we've got this. Yeah. So I love the way this is looking. Okay. Yeah. So I mean I'm very impressed that you guys are following. This can be very difficult for people to grasp. You people are in the spirit. Yes.
Why are we finding the variance
Of the estimator. Since we found the mean, let's find the variance. If we find, because we need to know the average value of the estimator, we also need to know the variability. And I made mention before, we have already stated the Guzman-Markov theorem. And the Guzman-Markov theorem told us that the variance of the OLS estimator is the minimum. We need to know what we are calling the minimum, right?
So we are basically proving the assumption.
Yeah, really, yes, we're putting ingredients together to prove the theorem. Yes, that's it. Outside that, you need the estimate of the variance for you to estimate standard errors. Okay, that's a story for another day when you come for PhD. Okay. Alright, so this is equal to yes, that would be very fine. Okay, yes. Inside this bracket. Oh, I think I have. I've done so several times. This is beta hat minus B. You know the reason why we are putting B here? Because B is the mean of what? Beta hat from this place. And then for us, you know, variance, I said variance is what? The expected value of x minus what? Expected value of x, then we square. The reason why we are bringing the transpose there is the transpose will take care of the square. Basically, that's what we are doing. Okay, now, since we have this becomes the expected value of, we need to bring in beta hat. What is the estimate of beta hat? X prime x inverse x prime what? Y. Great. Minus what? Minus this b. Right? You know, everything here is what we have here. Okay, we found the estimate, we'll just replace it. Then, this is for the first part. The second part, we just simply write again. X prime x, x inverse, x prime y minus b. But this time, we put a what? A transpose. So, that's it. Again, we don't want y to appear. Okay, we don't want y to appear. We just need to take away y. So when we take away y, we're going to have expectation of x prime x inverse x prime of what?
XB plus E.
Beautiful. Xb plus e. Very good. Minus what? Xb plus e minus b. Okay, we just rewrite it again and then transpose. So we have x prime x inverse x prime xb plus e minus b, then we transpose. Okay, transpose. So that's what we got. Now the next thing is what we're going to do next is we open up the brackets. So this gives us expectation of what? Use everything here to multiply what's in the bracket. We are going to get x transpose x inverse x prime x beta plus x transpose x inverse x prime e. Okay, we've opened that. We've opened the first bracket. Then it's the same thing. Just write the same thing. Oh, minus beta. Thank you. Minus b. So then we write the same thing here. X prime x inverse x prime x b plus x prime x inverse x prime e minus b. Okay. Prime. Yes. Okay. Please, I maybe you should stop writing. I'm not going to clean the board. Yeah, please stop writing and watch what I'm doing. Okay, because it's a little bit, it's getting complex now, and you need to observe. Okay, now here let x equal to x prime x. This is definition. Just chose x to the x prime x, so that this stuff can be, we can make it manageable, right? Okay, make x equal to just say x. So here we're going to write x will be equal to what? Equals to x inverse times x beta plus what? X inverse. You know there's an inverse, right? Okay. Then x prime e minus b. We resolve the first one. So we simply write it again. X inverse x b plus x inverse x prime e minus b. Then transpose. So that's it. Now we're going to proceed to the other side of the board. We check the variance of beta hat would be equal to, please follow me now. Okay, try and follow me now. This is going to go away, right? This is going to go away. It becomes 1. And so using the inverse to multiply the matrix. So we'll be left with b, right? As a matter of fact, the only thing that will remain here will be what? X inverse x prime e, because when we are left with b, b minus b, so that will go away. So that gives us the expectation of
X inverse x prime.
okay, x inverse x prime e. Okay. Then here we're going to have the same thing. Then transpose. Okay, we've reduced it. Yes. I should go back again. Okay, how did we arrive at this point? Okay, we arrived at that point because you see this x inverse times x is going to become 1. It's like saying it's like dividing 2 by 2. It's going to be 1. So we left with b, right? So since b is now left here, it becomes b minus b. That will also go. So we left with what? X inverse x prime e. That's it. And you know, whatever happens here will also happen on the other close brackets, right? Yes. This plus sign. Here.
Yes.
No, this is negative sign. Here.
Yes.
This is prime. Prime.
From the formula that was first, second, third row.
This one.
Third row. Yes.
Okay, the plus sign.
Yes.
We included it, didn't we? We use this to multiply everything here, right? And we got this. Then we use it to multiply E. So it's still there. Okay. So you guys already know how we got to this point. Now this is just simply product, right? So this becomes expectation of what? X inverse, X prime, E, then transpose, right? Now we need to transpose this matrix. Let's transpose the matrix. If you transpose this matrix, what's going to happen? It's going to be E transpose. Remember the order. Since E is the last one, it's not going to appear first, right? Okay, followed by what? Followed by what? X. So when you transpose an already transposed matrix, you get the X back, right? The transpose of the transpose is the matrix itself. So the transpose goes away. Now, when you transpose an inverted matrix, it leaves it the same. Okay, the transpose of an inverse is the inverse of the transpose. It's the same. The transpose of an inverse is the inverse of the transpose. The transpose of the transpose is the original matrix. Yes, the original matrix. That is, when you have a matrix and you transpose the matrix, when you transpose the transposed matrix, you get the original matrix. Okay, just breathe. Breathe a little. Okay, what I'm saying is the transpose of a transposed matrix is the original matrix. Put differently, when I have a matrix and I transpose it, the transpose of that transposed matrix will give me the original matrix. Then, secondly, if I have an already inverted matrix, okay, if I have an already inverted matrix, the inverse, the transpose of that inverse is the same as the inverse of the transpose. So the matrix is unchanged. Okay, that is why when we transpose X inverse, it's still going to be what? X inverse. Okay. Oh, to come to X? No, this is not a transpose, this is an inverse. Yeah, that's it. I know I sent you guys some materials on matrices, which I'm 100% sure you did not study. Okay, alright. It's fine, for last semester. I mean, I can't, if I tell you the pain I put into preparing that material, it was so exhausting. I mean, I put everything to make sure that all these laws I'm stating, they're all inside the material. Yeah, they're inside, yeah. After you graduate. Okay, let's go back. Now, you know this gives us, hello, please let's listen now. S inverse, X prime E, E prime, X inverse, right? Okay, E prime, then there is X, X inverse, okay. Now, if you check it out, these are constants, right? These are constant. S inverse is a constant. S is a constant. So, it means the expectation will only affect what? The error term, right? Yeah. Okay, so it means we're going to be having X inverse, X prime, expectation of what? E and E prime. Then X inverse. Very good. If you remember, we already have a value, a quantity for this. Right? In the assumption. Sigma squared. Thank you. So, it's going to be what? S inverse, X prime, sigma squared, X prime, X inverse. And also, we know that sigma square is a constant. We can bring it out. It becomes what? X inverse, x prime x, x inverse. Right? That makes sense. It's the same. It's a constant. We can always take it out. So this gives us x squared, x inverse, then x. Remember that x prime x, we defined it already to be x, right? And then we're going to be having what? X inverse. So what happens? These two will become what? 1. Right? Identity matrix. So what are we going to be left with? Sigma square x inverse, which is the same as what? Sigma square x prime x inverse. That is the variance. So this is the variance of beta hat. Now, we have obtained the variance of beta hat. Very big deal. I know. Yes. Yes. Please write. I'm not going to. Yes. I'm not going to take the ball. So, yes. And you go back again. Okay, I will. But after all, this is the last day. If you want to finish, no problem. Yeah.
So my question, when you expanded
Okay, can I take her question and I'll come back to yours? Okay, don't forget to ask again. Okay, now, you see what we have? Expectation of E prime of E. If you go back to the assumption, this has a value already. Okay, it's what? Sigma squared. So that's why we impose the sigma square here. It's just a constant, right? So we decide to take it to the back, sigma squared, then x prime x, then this x here. We already know that x prime x was defined as what? Just x, right? So that's how we obtain this. X inverse times x is going to be what? 1. That is takes care of itself as an identity matrix. So when that happens, we'll be left with just this S inverse. That's how we arrive at the last solution.